Today we're going to be learning about the triangle angle sum theorem. It states that the sum of the measures of the interior angles of a triangle is 180 degrees. So if we take a look at our picture, if I take angle A, add it to angle B, and add angle C, it will equal 180 degrees. So using this information, let's look at example 1 of how we can find the measure of each numbered angle. So if I first start off with finding the measure of angle 1, it already gives me the fact that it's a right angle based off of the square. So angle 1 is going to be 90 degrees. The measure of angle 2 is a supplementary angle with angle 1. It creates that straight angle. Supplementary meaning that it adds up to be 180. So if I took 180 and subtracted 90, I'd also get 90 degrees. The measure of angle 3 is also a supplementary angle with angle 1. It creates that straight angle. So that again means angle 3 is 90 degrees. So now the measure of angle 4, we're looking up here at the top part of our figure. 4 is actually a vertical angle with this degree over here. And based off of unit 1, vertical angles are congruent angles. So that means angle 4 is 130 degrees. We're going to sneak in a number right here and make this angle 5. So looking at the measure of angle 5 and angle 4 are supplementary angles. They form that straight angle. Same with angle 5 and this angle right here. So that means these two have to add together to be 180. So if I'm at 130, angle 5 is going to have to be 50 degrees. So that 50 plus 130 is 180. The measure of angle 6, that is also going to be 50 degrees because angle 5 and angle 6 are vertical angles, and vertical angles are congruent. So now let's look down here at angles 7, 8, and 9. The first one I want to look at, though, is going to be angle 8. We discovered that angle 1 was 90 degrees, angle 6 was 50, and we're now going to try and find 8. But if I take a look here, I am given a triangle right here. And based off of the triangle angle sum theorem, it states that 3 angles in a triangle add up to be 180. So if I took my 90 degrees and added to 50 degrees, we get 140. So if 3 angles have to add together to be 180, if I subtract 140 from that, that means angle 8 is going to be 40 degrees. Also, if you take a look, it tells us right here this angle is 40 degrees and angle 8 is a vertical angle, so that means that they're congruent, so it's also going to be 40, but I wanted us to make sure we looked at it through the eyes of the triangle angle sum theorem. So now angle 7 is a supplementary angle with angle 8, meaning these two have to add together to be 180. So if angle 8 is 40 degrees, angle 7 has to be 140 degrees. Angle 7 and angle 9 are vertical angles, so that means they are congruent. So angle 9 is also 140 degrees. So now we're going to be looking at how to classify triangles by 2 different views, by angles and sides. When we are talking about a triangle that is acute, that means all angles are less than 90 degrees. An obtuse triangle means that we have one angle that's greater than 90 degrees. In a right triangle, we have exactly one angle that equals 90 degrees. And equal angular means that all angles are equal. And if all angles are equal, we know in a triangle they all have to add together to be 180. So if they all are the same, that means all angles will have to be 60 degrees. Because 60 plus 60 plus 60 gets us 180. There's no other way we can get that. So now if we're looking at naming them, classifying by sides, first one we have is a scalene triangle. That means that no sides are equal. An isosceles triangle means that we have two sides are equal. And equilateral means all sides are equal. If we have an equiangular, then it means we have an equilateral triangle. If we have an equilateral, that means we have an equiangular. So if you know all sides are equal, that also means all angles are equal. So let's look at what's given to us, and we're going to classify the triangle based on what's given. So I am given that sides are 8, 4, and 5. So I'm looking at my sides. None of them are the same, so that means I have a scalene triangle. Now I'm given side lengths of 5, 5, and 8. So I have two of them that are the same, so that means I am dealing with an isosceles triangle. And lastly, I have my angles, so I'm dealing with, looking over here, I have 100 degrees, 30, and 50. Well, I have one angle that's greater than 90 degrees, so this means it's an obtuse triangle. So we are going to now look at example 3, which is to draw and mark a triangle to fit the description. So I have an acute scalene triangle. So acute meaning all of my angles are going to be less than 90, and scalene meaning no sides will be the same. So if I try and draw 3 angles, those look like they're all about, that they're acute, they're less than 90. So if I want to show that these sides are not equal, I would put different tick marks. So this has 1, 2, then 3. That means that none of these sides have the same length. So that would be an acute scalene triangle. An isosceles right triangle. So the first part, right, meaning we have a right angle. So I'm going to draw a 90-degree angle. So I have my right. To make it isosceles, remember isosceles means you have two sides that are the same length. So that means my two sides will have to be my legs, and I'll put a mark on them, and they have to be the same to represent the fact that they are the same length. An obtuse equilateral triangle, obtuse meaning greater than 90 degrees. Equilateral means they have all the same sides. However, if they have all the same sides, that means they have to have the same angles. So that means this is not possible. We cannot have an obtuse triangle that has the same side lengths. And lastly, let's look at our exterior angles. An angle that is outside of the triangle is an exterior angle. So if I'm looking at this picture here, this is my exterior angle. Remote interior angles are two angles that are not adjacent to my exterior. So again, if this is my exterior angle, it's on the outside. My remote interior angles are not adjacent to it. So if I'm looking at this angle inside my triangle, that is adjacent. So this is a remote interior angle as well as this one. They are not adjacent to my exterior. So the triangle exterior angle theorem states that the measure of an exterior angle of a triangle is the remote interior angles added together. So if I'm taking a look here, if these two, we'll call this remote interior 1, remote interior 2. This is my exterior. In order to find this, if I take my remote interior angle 1 and add it to my second one, it will equal my exterior angle. So using that information, let's look at example 3. It tells us that angle S is 58 degrees. Angle R is 63 degrees, and I want to find all the other angles. So I want to find my last interior as well as my exterior angle. So if I'm trying to find my exterior angle right here, I know I need to take my remote interior, which these are my remote interior, and add them together. So if I take 58 plus 63, I end up with 121 degrees. So that means my exterior angle is 121 degrees. So to find my last interior angle, I know that these two angles are supplementary. They create a straight angle. A straight angle means these two have to add together to be 180. So if I take 180 and subtract 121, we get, what do we get? We get 59 degrees. So this last angle inside is 59 degrees. For our last problem, we need to find the value of the variable. To look at this from the standpoint of an exterior angle, we actually want to identify what this angle is right here, because that will be the exterior angle I'm dealing with. So if I'm looking here, I know that these two angles are supplementary. They create that 180 degrees. So if I take 180 and subtract 101, we're left with 79 degrees. So my exterior angle is 79 degrees. So using the exterior angle theorem, this is my remote interior and my second remote interior angle. If I take both of those and add them together, they have to equal my exterior, which is 79. So if I subtract 58 to both sides, I get that my missing angle is 21 degrees.